So my name is Gajendra Deshpande, and today I'm going to deliver a talk on fighting money laundering with Python and open source software. So in today's talk, we are going to discuss these topics in brief. So first one is forensic investigation process, then double standard and the Python, then bank account analysis or fund trail analysis. So that's the main crux of anti-money laundering. Then how are we going to do it? So there are basically three concepts here. One is Benford's law, then second one is visualization, then third one is logging. And finally, I'm going to conclude my talk.
Sorry, Gajendra, you're currently on the PowerPoint slide and not the shared screen slide, I believe.
Okay, just a minute. So now is it okay?
Yeah, looking good now. Thanks.
Yeah, thank you. So let's start the discussion with forensic investigation process. So there are basically 6 steps. First one is identification, then second one is collection, third one is validation, fourth one is examination, fifth one is preservation, and finally presentation. So what happens in identification step is that investigative officers visit the crime location, crime scene, and they are going to collect all the objects of suspects. Now, in case of anti-money laundering, they are going to identify the suspects and approach the banks and collect their bank statements. This is very important. And in usual forensic investigation process, they will also take into consideration, take into their custody different devices, different electronic devices, including pen drives, toy pen drives, hard disk, computer, mobile, etc. And one of the important aspect to note here is that they have to preserve the state of the machine. That is, if the system is on, they should not turn it off. If the system is off, they should not turn it on, because there can be evidence that can be present in the volatile memory, and there is the order in which they have to collect the evidence, and the order is they have to collect the evidence from most volatile memory first and least volatile memory last. Then once they identify the different objects, the next step is collection. And when they're collecting, they have to store all this information, all these devices in special plastic bags. They're also called as electrostatic bags or Faraday bags. And they have to make sure that the evidence is not tampered. Then after this, they have to perform validation. So generally what happens is that they also take the snapshot of the system, right? And in our case, they are going to work with the soft copy of the bank statements. And it may happen that whenever we are performing some analysis, some softwares may alter the information. And if it alters the information, then it may create a problem in the code. So they have to make sure that the software doesn't interfere with the evidence. So that's why they always work on the copy of the data. So we're going to see how are we going to validate the information, whether the information is altered or no later with Python codes example. So right now I can say that you can make use of hashing algorithms for that to preserve the integrity of the information. Then fourth step is examination. So here what happens is that we usually get evidence in different pieces. Okay, and in examination step we are going to process the evidence, we are going to analyze the evidence and find the correlation between different pieces of evidence. So that is very important here. The next is preservation. So all the evidence, all the objects, whatever are collected by the investigation officers, they need to be stored at proper location, properly in the safe, at appropriate temperature, right? So with proper passwords, encryption mechanisms, and so on. They have to make sure that the information is not tampered, nobody is accessing the information. Then final step is very important, that is presentation. So there is a particular format in which all these steps have to be carried out, and it needs to be presented in the court of law. If you don't follow the procedure laid by the investigation agencies, then your evidence may not be accepted in the court. So that's why you have to follow the steps specified by law enforcement agencies here. That is very important. Okay. So next we are going to see is the double standard and Python. So basically in the United States federal law, there is something called as Daubert standard. It's also called as the rule of evidence. And it's regarding the admissibility of expert witness testimony. So here a party may raise a Daubert motion, a special motion in limine, raised before or during trial. So to exclude the presentation of unqualified evidence to the jury. So this is very, very important here. Okay. Then there are some illustrative factors set by the court. And court says that these all come under scientific methodology as the process of formulating hypothesis and then conducting experiments to prove or falsify the hypothesis. And these are provided by some set of illustrative factors. And Supreme Court suggested the following factors. So first is, has the technique been tested in the actual field conditions and not just in laboratory? Has the technique been subject to peer review and publication? What is the known or potential rate of error? Then do standards exist for control of techniques operation? And last one is, has the technique been generally accepted within the relevant scientific community? So in this slide, we'll see how the illustrative factors mentioned in the previous slide are related to Python, or how they can be mapped one to one with Python programming language. So in 2003, Brian Carrier published a paper that examined rules of evidence standards, including Daubert. And he compared and contrasted open source tools and closed source tools. And one of the key findings was that using the guidelines of Daubert tests, open source tools may more clearly and comprehensively meet the guideline requirements than would closed source tools. Then the results are, of course, not automatic because just because the source is open, but there are some specific steps that must be followed regarding the design, development, and validation. So now we'll see one-to-one mapping of the illustrative factors with open source programming languages. So now we can ask these questions. Can the program or algorithm be explained? So this explanation should be explained in words, not only in code. This is very, very important statement. That is because people who are working in law, they may not understand technology. So they may not understand the technical jargon of a programming language. Okay, so it has to be explained in simple terms. Then has enough information been provided such that thorough tests can be developed to test the program? The third one is, have error rates been calculated and validated independently? The next one is, has the program been studied or peer reviewed? This is 100% possible because whatever code you write is available on GitHub and anybody can review it. And has the program been generally accepted by the community? Yes, so Python is widely adopted programming language. Now, if you consider these things, we can speak with respect to Python, but you can also speak with respect to any open source programming language such as Julia. So now let's see the problem, that is bank account or fund trail analysis. So the most common and continuing offense in recent times is that of money laundering. So to make it easier for the police to trace the illegal origin of money and undo the complexities created in a series of bank transfers, so police department was looking for a solution that facilitates efficient analysis of bank accounts to identify the links among them. So this was a very, very famous problem. So this problem was given by many law enforcement agencies in many hackathons. So we thought that this is a very prominent problem to solve. So now let's see what are the examples of money laundering. So the first example is that trade-based laundering. So this technique involves manipulating invoices to disguise the movement of money. So for instance, person might export goods of $10,000 and produce the inflated invoice of $20,000, and then extra $10,000 money can be claimed as clean money. Then there's something called structuring or smurfing. So this involves breaking down large amounts of cash into smaller, less suspicious transactions These transactions are usually spread out over time and possibly across different financial institutions to avoid detection. In our solution, we are going to focus more on structuring or smurfing. So we are going to detect such cases. The next one is offshore accounts. So money is deposited into offshore accounts that offer greater secrecy and are less regulated. The money might be moved around several times, making it difficult to trace its origins. Then there is another way. Some people may establish shell companies or fake companies or trusts. So criminals create fake companies and trusts to disguise the true origin of money. So these companies may just exist on paper, but they don't engage in any legitimate business activities. Then there are some more like gambling. So individual might buy casino chips with illicit money and then cash them out later for clean money. Then intentionally they may lose bets to another party who is on the scheme. Then Bitcoin and cryptocurrency. So with the rise of digital currencies, criminals have turned to cryptocurrencies as another way of launder money due to its anonymous nature. And one more important point to note here is that nobody has control over cryptocurrencies. No government can control. So that's why you can see that many times cyber criminals demand ransom in cryptocurrencies or bitcoins. Then overseas real estate. So invest black money into or dirty money into real estate is another common tactic. So the property is bought with illicit money, then sold, and then proceeds are considered clean. The next concept is politically exposed persons. It's also short for PEPs. So PEPs are individuals who have been entrusted with prominent public functions, for example, heads of state or government, senior politicians, senior government officials, military officials, senior executives of state-owned corporations, and so on. Then there can be international organization PEPs. So here persons who are or have been entrusted with a prominent function by an international organization. So refers to members of senior management or individuals who have been entrusted with equivalent functions such as directors or deputy directors or members of the board of international organization PEPs. Then there's something called as family members, or you can also call them as RCS, relatives and close associates. So family members are individuals who are related to PEP, that is politically exposed persons, either directly or through marriage or similar civil forms or partnership. Then close associates. So close associates are individuals who are closely connected to PEP, either socially or professionally. Then there's something called as FATF, that is the Financial Action Task Force. FATF was established in 1989 and is based in Paris. So it leads a global action uh, to tackle money laundering, terrorist and proliferation financing. So it researches how money is laundered and how and terrorism is funded, promotes global standards to mitigate the risks, and assesses whether countries are taking effective action. So in total, more than 200 countries and jurisdictions have committed to implement FATF's standards, and FATF's decision-making body, that is called as the FATF plenary, meets 3 times per year and holds countries to account if they do not comply with the standards. So you can refer to the link given in the slide for more information and activities about FATF. So this slide shows how money laundering happens. So this is basically concentrating on structuring or smurfing. So there are 3 layers. One is placement, second one is layering, and third one is integration. Okay. In the placement stage, sender divides the large money into small chunks and deposits into multiple bank accounts. Then after multiple bank accounts, there will be series of transactions and it goes through multiple bank accounts again, sequence of bank accounts. Now on this slide, you can see here that there are some transactions which are highlighted in red arrows, some are in green arrows. So you can consider for understanding purpose, green arrows means it's a legitimate transaction, red arrows means it's a illegitimate or fraudulent transaction. Okay. So after layering stage, there's the integration stage. So at the end, so money from these multiple accounts will be deposited into receiver's account. So if you see the structure here, it's called structuring or smurfing, and we are concentrating on detecting such fraud. Then the proposed solution. So what are we going to do here? So first, in the first step, we are going to collect the bank statements from different banks, and we are going to create the data set of accounts. And there is a challenge here. The challenge is that each bank generates bank statements in their own formats. In some banks, credit amount may appear first. In some banks, debit amount may appear first. So the challenge here is to consider all these multiple bank accounts and bring them to uniform format. That is, we have to map credit amount to credit amount column. We have to map debit column to debit amount column. Now we can apply here Benford's law. So we'll see what is Benford's law. So Benford's law gives us some indication, some hints of possible money laundering. Then after that, we have to import data of suspicious accounts. And here we also need to consider whether these accounts are related to PEP, RCA, or even sanctions data. Then generate a graph showing links between accounts and transactions. Then apply machine learning on the graph. Then predict the possible money laundering. And generate the chain of accounts with fraudulent transactions, because here investigation officers, they want to know the entire chain of transactions. Now on the left side, you can see here that I have mentioned record all steps for evidence verification and validation. This is a very, very important step, because this is not a normal software. This is a forensic software. Okay. So we have to record each and every activity and prepare a report, because in court, our opposition lawyer may ask how you have arrived at the solution. So in that case, we have to provide all this evidence. So one of the greatest features of forensic evidence is that, or forensic software, is that it has to be reproducible. Let's see what's Benford's law. So it's a phenomenological law, and it's also called as first digit law, or also called as leading digit phenomenon. So Benford's law states that in listings, in tables, or in statistics, so digit 1 tends to occur with probability of 30%, much greater than the expected 11.1%. So there is no equal uh, probability. So in this table, you can see it is clearly mentioned for each digit what is the probability of occurrence. For digit 1, it is 30%. For 2, it is more than 70%. For 3, it is more than 12%. For 4, it is more than 9%, and so on. And this is the formula. P of D is equal to log to the base 10, 1 plus 1 by D. So where D is values of the leading digits from 1 to 9. And whatever graph you are seeing here, right, this is the expected graph. Okay. In forensic investigation process, we had discussed something about validation. Okay. So here, how to make sure that your data or information is not modified. So you have to make use of hash functions. So in Python, you have a hashlib module, import it. So use the different algorithms present over here. So we are using SHA-256. You also have SHA-1, SHA-2, MD5, and so on. And you can see here that we have defined a message. So the message is broken into uh, two two messages. So in first message, I have Python easy, and in second message, I have a great programming language. And we are computing message digest. Okay. And we see here that when the message digest matches, that means there is no modification or alteration of the evidence. But in the second example, you can see here that for message X, I have added extra space. So in this case, it is showing the output as false. That means there has been some evidence of modifying or tampering of the evidence. So now let's see how to apply Benford's law here. So first, import the necessary libraries, pandas and numpy, and also matplotlib, because we want to visualize the things, and define the percentages. So these percentages are, these values are mentioned as per the Benford's distribution. Then read the bank statements through CSV. Then next, plot the graph, and then compute the deviation. So we cannot have actual values here. So actual matching is not possible. We have to consider some error margin, some deviation range we have to consider. And if it is within the deviation range, then there is no possible money laundering. Otherwise, there can be possible money laundering. So similarly, in Python, there is a library called as Benford's law. You can import Benford's law package directly. So it's a very simple library. So you can use pandas to read the bank statements, then directly apply Benford's law over first digit, and there can be chi-square method that can be used to perform statistical tests. Then you can apply the Benford's law algorithm using fit function. So compute the significant p-value, and if Benford's value is greater than chi-square value, then you can say that anomaly is detected, and plot the values using plot function. Okay. So similarly, you can extend the code for second digit as well as third digit if you are much interested. Yeah. So see here, this is the graph you get here. Although it closely resembles Benford distribution, but it is not matching, or it is not within the deviation range. Okay. For example, first case. So it says 35.1%, right? So there is obviously deviation. Okay. So that's why we can say that there is anomaly detected. That means there can be possible case of money laundering. This is for second digit and third digit. Okay. So next, we have to visualize the things. So we have to show the relationship between different bank accounts if there is money laundering. So for that, we can make use of library called as Network X. Okay. So again, read the transactions or bank statements, then use digraph, because we have to show the arrows from node 1 to node A, that is from bank account A to bank account B. There is a amount transfer that we have to show with a graph. So that's why we are using digraph method. So there will be always a source account and target account. So arrow is from source account to target account, and depending on the number of transactions and the amount of transactions, the weight of the edge can be darker or lighter. So similarly, draw the graph, and you can see this is the sample output. So we have assumed hypothetical accounts and hypothetical transactions between accounts. So that's why you can see here that between some accounts the arrows are dark, and in some, with some accounts the arrows are more light. So that means darker arrow indicates more number of transactions, more amount of transaction. Lighter arrow indicates less number of transactions and less amount. Then logging module. Since it is a forensic software, we have to implement logging module, and we have to record all the activities. To record all the activities, logging module plays very important role, and it is available fortunately in Python. So it's a built-in module used for flexible event logging, and there are some key components with respect to Python's logging module. So we have logger, we have log record handler, and formatter. So extending the previous program, so you can see here we have set up the logging process by using logging.basicconfig function. So define the file name that's called as app.log, and it's open in write mode because we want to write everything to some file. So we can call it as log file here. Then what type of message you want to add? I want to add informational message, so I'm saying logging.info. If you want to note down error message, then you can say logging.error. So once you do this, you're going to record all the activities. You're going to prepare a report, and you can submit that report stating that this is how we have got the output, or this is how we have arrived at the solution. Okay. So finally, the conclusion. So functional analysis is very complex, and more advanced techniques and tools are required. So it's not so straightforward as I have shown it in the slides. Okay. Thank you everyone for your time and listening to my talk. If there are any questions, I can take them.
Looks like we don't have any questions for now, but let's wait for like 1 or 2 minutes.
Sure, Nikhil. Thank you.
Gajendra, I might have a question. Do you have any resources from your end for someone who is interested in getting into forensics regarding money laundering? How can someone get into this field?
Yeah, I had seen some online courses which specifically deal with money laundering, and you can explore something called as forensic accounting. So those who are from uh, finance background, okay, so they can explore something called as forensic accounting.
Okay, we have one question in the chat. What kind of algorithm will you apply on the graph?
Yeah, so we have to represent the graph information into data set or sequence of transactions, and maybe we can here we have to make use of classification machine learning algorithms.
Another question for you is what do you do after with all the graphs?
Yeah, so graphs are basically visualization techniques. So it shows what is the relationship between different accounts. So you might have seen in one of our slides that some arrows were darker, some arrows were lighter. Okay, so we may ignore some of the lighter arrows, but if we see that the arrow is darker, then that means that there are more frequent transactions, more amount of transaction is involved, and that may be a possible hint for the investigation officer that okay, there may be possible money laundering. Okay, but finally it is just assist the investigation officers. Okay, so it's the investigation officers who has to investigate it and identify whether it is true positive or false positive, but it just gives some hints, some indication that there can be possible money laundering.